In Japan, some years ago, farmers found some rice paddies in their fields that grew very tall in an amazing rate. And then, when it couldn't resist any more of its weight, it simply broke and fell to the ground, dead. The Japanese scientist Eiichi Kurosawa studied this case and he discovered a fungus living on the plant, causing the plant to grow very fast and elongate in an exaggerated way. So in the end, the plant will end up dying and falling to the ground. What he actually found out was that the fungus increased the concentration of a specific hormone in the plant. The name of this hormone is gibberellin, and it is a chemical messenger like many other hormones in the plant. In a cell, there is a specific part for the creation of a hormone. This happens on a part called the plastid. Through the process of protein synthesis, a new hormone is made and it is released from the cell to deliver a particular message to another part of the plant. This cute little fellow actually looks like this because it has a specific chemical structure. So when this hormone is released, it travels through different parts of the plant to reach the specific action sites and have an effect on the plant. In any action site of the plant, the message is received. And now that the cells from this part of the plant have the instructions that another cell has sent with the gibberellins, they can perform specific functions with an effect on the life of the plant. Gibberellins have an effect on the dissolving of the starch, bud and seed germination, wakening from dormancy, flower and fruit development, root lateral growth, and stem elongation. Now you will see the effects that happen in a plant with gibberellins. In a dormant plant, gibberellins will be sent from a site with high concentration of gibberellins from a place with low concentration. This will wake up the plant from its state of dormancy. And so the plant can go on working normally like before. The plant will elongate and grow. The bud of the plant will open and the flower will develop. At the same time, in the roots of the plant, gibberellins will spread simultaneously to promote the growth of lateral roots. All at once, gibberellins are spreading through the plant so that the starch is dissolved and it can be used as new material for the growth of the plant. Another effect that will happen to the plant because of the gibberellins is the development of the fruit. Scientists kept investigating this hormone and they came up with an idea of making a product of gibberellins commercial. They thought that selling gibberellins could only have a positive impact in agriculture. And today, people use gibberellins in agriculture to make seedless grapes grow bigger and better. By applying a spray of gibberellins to the grapes, we'll make the grapes at the end bigger and of a better quality. These grapes don't have any gibberellins applied by humans. But then you can see the difference between these grapes with no extra gibberellins and the other grapes that are in bigger clusters because humans had applied extra gibberellins to the grapes. Even if it might seem very good for humans to create big seedless grapes of good quality, it isn't easy to make these plants reproduce since they don't have any seeds. What is done is that a piece of the plant is taken away and planted so that it reproduces asexually, and this new plant is practically a clone of the original one. These clones are more susceptible to diseases, and if the original plant gets a specific illness, the clones will probably get it too. And in the end, all of the traditional and more natural agricultural traditions are being lost and replaced by new ways that have much more chemicals.